Hello guys, welcome to my channel. Today the topic is about malloc, calloc, free and realloc. These are the library functions which we use for dynamic memory allocation. Before going to the topic of malloc and calloc, we will know what is a dynamic memory allocation. See, an array is a collection of a fixed number of values. Once the size of array is declared, you cannot change it. Sometimes the size of array you declared may be insufficient to solve this issue. You can allocate a memory manually during a runtime. This is known as a dynamic memory allocation in C program. For simple and short, if the array which we created of size 4, if that memory was insufficient, we can increase that memory by using a dynamic memory allocation. Clear? This is an example. See, array of size 4. In this 4, if this size 4 was occupied with 0, 1, 2, 3. 4 elements were occupied in the size 4. What if I have to insert elements 4, 5, 6, 7? Size is 4. I am trying to insert more elements in size 4. We cannot do that because its size is 4. It can occupy only 4 elements. In order to achieve this, we use a dynamic memory allocation during a runtime. In dynamic memory allocation, we can increase the size of array during a runtime. That is the main use of a dynamic memory allocation. If the memory was insufficient, in order to increase the size of a memory, we use a dynamic memory allocation. See, for dynamic memory allocation, we use a certain library functions. There are 4 types of a library function which you use for dynamic memory allocation. For accessing this library function, we use a stdlib.h header file. While we are using this library function, we need to use a header file stdlib.h because the definition of this malloc, calloc, free and realloc will be defined in this stdlib.h. Clear? These dynamic memory allocation will be takes place in only heap memory. Here, local variables, these all variables will be stored in a stack, but dynamic memory allocations will be done in a heap. We have a memory management called like we have different types of memory management like stack, heap, data segments, text, these all things. In that memory management, while we are creating a dynamic memory allocation by using a malloc calloc, these memory allocations will be stored in a heap memory. This is very important. Malloc. What is a malloc library function? Malloc name itself we can see a memory allocation method in C. It is used to dynamically allocate a single large block of memory with a specified size. Here, it returns a pointer of type void which can be cast into a pointer of any form. See, this is the syntax. See, pointer equal to typecasting here. This is the typecasting syntax. Malloc and n is the user defined size. User will give this n size and size of int. Clear? This is the syntax of a malloc. Here we can see the example here. I am taking a pointer, int pointer I am taking. Here int pointer I am taking. I am using a malloc here, malloc function. I am allocating a memory of 4. I have given size n as a 4. And 4 into size of int. Consider this is as a 32-bit compiler. The int size will be a 4 bytes. 4 into 4, 16 bytes of single block of memory will be allocated with this malloc function. Clear? 4 into size of int will be a 4 bytes. 4 into 4, 16 bytes of memory. Single block of memory. Single block of memory will be allocated in the heap. After allocating, the malloc will return a void pointer. See, I have taken a int pointer here. If it returns a void pointer, it's a abnormal, right? After allocating a memory, the malloc will be returning a void pointer. This void pointer will be typecasted to int pointer. This is a typecasting will point to a into pointer. Since we have taken a into pointer here, since we are taking a into pointer here, we are typecasting into a into pointer which is a void pointer. Malloc will return a void pointer and will typecast into into pointer since we are taken a into pointer. Clear? Malloc. Overall, malloc is used for creating a single block of memory dynamically in heap. Clear? Example program of a malloc. See, I'm using a header file stdlib.h. Since I'm using malloc and calloc and free here for understanding, we cannot access the malloc and calloc if you don't have a stdlib.h. Whenever you're writing a program for dynamic memory allocation by using a malloc, calloc, free or realloc, we need to use a header file stdlib.h. I have written a code into main and I'm taken a pointer into pointer and I have taken a int n equal to 2 defaultly, and this pointer is pointing to the dynamic memory allocation. I have allocated a malloc n into size of int. Here size of int is 4 bytes. What is n here? I have defaultly declared n equal to 2. I have defaultly given a size. It means 2 into 4. It means 8 bytes of single block of memory will be allocated. See, by this thing, by malloc n into size, we are creating a 8 bytes of memory, single block memory. After creating a memory dynamically, it will return a void pointer. Malloc will return a void pointer and it is typecasting to int pointer since the pointer is int type here. Clear? Since the pointer is int type, we are typecasting to a int here. This is very important. We need to typecast the return type of a malloc and calloc every time when we use a malloc. See, after dynamically memory creation, I have created 8 bytes of single block of memory, 2 into 4, 8 bytes. In that, I'm assigning in 1 byte 10, and in second pointer, next address, I'm assigning it 20 here. For reference only, I have taken this. Only I'm allocating. I have assigning in only in 2 bytes. First byte I'm assigning it 10, and second byte 20. I am trying to print that values here. See, I'm actually int equal to 0, I less than 2. It means 0 and 1. What is in the 0? Address of 0 will be 0 byte will be a 10 and the first byte it will be a 20, and 10 and 20 will be printed here. Clear? For understanding very simple and short, I have assigning in the first byte as a 10 and second byte as 20, and we have created of overall of 8 bytes of single block of memory, but I am occupied with only 2 bytes. Remaining 6 bytes will be empty. For understanding, I have taken only 2 bytes here. Clear? Here, after allocating a memory, I am deallocating a pointer here. It means I am using a free library function for deallocating a pointer here. Free, I am using a pointer here. Whenever we are allocating dynamically through malloc or calloc, we should free that memory. Calloc. Name itself you can see as a contiguous allocation method in C used to dynamically allocate the specified number of blocks of specified type. It initializes each blocks with a default value 0. Clear? See, syntax will be same, only the difference is here. In malloc we will use a malloc, here we will use a calloc. And in malloc we use a n into size of int. Here I am using a n comma size of int. See, here we use the example. I am taking into pointer and I'm using a calloc 4 comma size of int. It means for the 32-bit compiler, the size of int will be a 4 bytes. Here I'm using a 4 comma 4 byte. It means 4 blocks will be dynamic memory will be created as a 4 blocks, and each blocks will having of a 4 bytes. Clear? In the malloc, we have a single block of memory will be created, but in the calloc, by seeing the syntax 4 comma 4, it means 4 blocks will be allocated in the heap. Each block is of a size 4 bytes. See here, this is the example program. Example of the memory allocation. See, each block is of 4 bytes, 4 bytes, 4 bytes, 4 bytes. Overall, it says 16 bytes, but each block it says 4 bytes of a memory will be occupied in the heap. And after memory allocation, will be initialized to 0. Each block will be initialized to 0. But in malloc we are not initializing, just we are allocating a single block of memory in the malloc, but we are not initializing to 0. But in calloc we are initializing to 0 after creating a separate blocks of memory in the calloc. This is the point. It is a initialize each block with a default value of 0. Here, if you're trying to access this block with this pointer, it will return as 0 since we are initializing to 0. But we are trying to access the malloc, we will get a garbage value since we are not initializing to 0. That is the main difference between calloc and malloc. Example program of calloc. See, the functionality wise the calloc and malloc will be same here, but internal memory occupation will be different in the heap. In the malloc it will be a single block of memory, in the calloc it will be a separate block of memory with size of 4 bytes each. See, calloc I'm using 2 blocks of memory will be created and size of it will be a 4 byte. Each block will be a 4 bytes. See, calloc also will return as a pointer, and the pointer is converted to a int type since we have a taken as a int pointer. And the first byte I'm occupied with a 10 and second I'm occupied with a 20. I am trying to print that variable for a short and simple reference. This is the program. You can execute this program in the online compiler and you can check this output. The output will be a 10 and 20. Just I'm checking only first 2 bytes of memory. Clear? Realloc. The name itself you can see a realloc means reallocating a memory which was already allocated dynamically. But suppose we have dynamically allocated memory by using a malloc or calloc, that memory we feel like it's insufficient. We feel like insufficient means we can reallocate. It means we can increase the memory again by using a realloc. This all text tells like same thing. See, I'm taking a syntax here, pointer equal to realloc and a pointer new size. If you have to give a new size, you can take this as an example. See, I'm taking into pointer. First, I'm using a malloc. I'm dynamically memory allocating. See, 3 into 4 bytes, 12 bytes of memory I'm allocating. And in the runtime, you feel like this 12 bytes of memory was not sufficient, then you can use a realloc. See, I'm using a same pointer here, realloc and point ptr comma 5 into size of it. It means 5 into 4, 20 bytes of new memory, single block memory is created. First we have created a 12 bytes of single block memory before realloc. And after that, while I'm using a realloc, I'm creating a 5 into 4, 20 bytes of a memory is created in a single block of memory in a heap. Clear? Realloc is mainly used for increasing the size of already dynamically allocated memory. That's the main use of a realloc. See, this is an example program of a realloc. Here also I'm using a header file here for accessing the malloc and realloc and free. See, I have using a pointer in pipe. I'm using malloc and assigning and default I have taken a 2 into size of int. 8 bytes of memory will be allocated and I'm occupied with the 10 and 20 in the first 2 bytes and I'm printing this 10 and 20 and I feel like this memory was 8 bytes was insufficient. Then I'm using a realloc here with the pointer and new size. New size I can give a 4 into size of int. 4 into 4, 16 bytes of memory I can assign, can allocate. See, that's the main use of a realloc. After allocating a memory, it's a good habit to deallocate that memory which has already dynamically allocated. Free is the library function used for deallocating the memory which was allocated dynamically by using a malloc or calloc. See, free, by seeing this pointer, it will deallocate the memory which we have created dynamically with malloc. That's the main use of a free library function. You can execute this program and check in the compiler. You'll get the same output and you'll get an idea how to access this memory. Hope you all guys are clear about this topic from this video. And the next video I would like to explain about what is the difference between the malloc and calloc and about the interview questions very clearly. And for further updates of my videos, please share and subscribe my channel.